I am going to walk you through how to do the lab that we did involving the cars, the tracks, and the Photogate. So here's my car, got a nice blue car. I have a track, the track is what it's going to launch on, and I have my Photogates that are going to be able to calculate different times. So first things first, the one thing it has you start off with is identifying what is taking place within the Photogate itself and how to connect that to the timer. So it all starts off with, let's get a little bit of power here. Let's turn the power on. I'm going to push this all the way over to interval. And I'm going to signal, I'm going to turn the power on to just where it says letter A. And A is actually going to be able to measure, let me get this sorted out. Let me get a couple practice runs for some consistency's sake. So 0.0065. So here's what I'm looking at. The first part of this lab, the first part here, is determining what happens when the Photogate is running or measuring time. And essentially, if I'm blocking this with my hand, you'll see that the timer's running. If I move my hand out of it, right, see if I can get them both on the screen, boom, it stops. And if I do it really quickly, it's just gonna be a much smaller time on my digital readout here. And so therefore, really quick is gonna have a noticeably smaller time. So here's what we have going on. The key to this is that the Photogates, right, if I tell it A, then that's measuring the time in which the sensor is being signaled within the Photogate itself, is measuring how long it's blocked for. And therefore, if I trigger Photogate A and Photogate B, it's measuring the time, in theory, for how long it was interrupted for. So let's see if we can get this. Yeah, okay, that time it worked. So I don't really have to hit reset, but I will for this one. So notice if I launch the car, I'm going to launch the car. So now we'll get into the lab itself. Just kind of the basics here. In this case here, Photogate A, the time in which it took for this flag, this 1 centimeter flag right here, to interfere or impede that sensor was 0.0063 seconds, right? That's 63 thousandth of a second. Well, in this case, Photogate B was interfered with a time of 0.0069 seconds, right? That's how long it took the Photogate to travel through here. And then lastly, when A and B lights are on, it tells me how long it took for this car to get from Photogate A to Photogate B. And so the basics go a long way here. It took 0.1277 seconds to travel from A to B. It took 0.0063 seconds for the car to travel or interfere with the Photogate A, and it took 0.0069 seconds to interfere with Photogate B. So what we're going to look at, and what we're going to make sure we move on here with, and I'm just kind of help you with this one, is that just because the Photogates are on or off, just because they're not on, doesn't mean they're not collecting times. And that's the key here. That the times are simply, I just need to push the button, 0.0064, 0.0070, it's still collecting times here. So if they're on, it simply is just showing up on the digital readout. Even if they're off, it's actually still collecting times. It's just you have to tell it what you want it to see or what you want the information for. Photogate A, Photogate B, and time to get from Photogate A to B. So I think of these ons and offs here simply you just haven't instructed it to turn it to you need to tell it what information you want to get from it. So on, it's only telling me, right, it says, with this setup, how do you start the clock? Well, you simply interfere with this Photogate. How do you stop it? Well, that means you remove it from the interference of the Photogate, right? How do you stop it? So as soon as you block the sensor, it begins clocking. As soon as it comes out, it stops timing. So really we're looking at interfering with the Photogate sensor. Moving on here, the parts A and B. Part C here, when you put the tracks together, we are going to make sure that, I'm just going to do parts A, B, and C here right now. So part C is simply, the key to this entire lab is to make sure that your Photogate is 0.001 seconds, there's consistency here. So it's really like saying this. If I keep all things constant, all things being equal, and I pull this back to an equal distance every time I'm pushing back here and I let go, my time for Photogate A should all be within 0.001 seconds. So I'm going to run some trials for you just to make sure we understand how this works. So if I'm looking for consistency. Consistency. And that means I need all of my times within 0.0001 seconds, right? That's 1,000th of a second. So I've got tenths, hundredths, thousandths, 1,000th of a second. So let's see. My first one I did here was 0.0068. Let's see if I'm consistent here. And I'll keep the, it's kind of hard. I'm doing this all by myself, so I'll try to do this. Let me switch hands. All right, let's see if I get consistency. So I had my first trial was 0.0067. My second trial is 0.0063. Notice these would be legitimate. I could use this data. Let's try a couple more. 0.0065. And one more time just to emphasize the point, 0.0068. So that's just simply saying that I'm consistent. I am within this 1,000th of a second, that I could trust all the data that comes after it, that all of these are consistently within that time frame. Matter of fact, my range here would be from 0.0063 to 0.0068, which is a difference of 0.0005. So I'm within that range here. So consistency is important here. And really, if you don't get the consistency with this time right here, you cannot complete the data. Matter of fact, you have to redo the lab, and that's just very time consuming and painstaking. Okay, so I just walked you through parts A, B, and C. If you look down here at this part right here, hopefully you realize that if it's a constant speed, your times will be the same. And if you, all things being equal, if the times are different, that simply is telling me that the speed of the cars is changing. And so therefore, if I look at this in terms of times, if I see that it takes 0.0068 seconds to travel through photogate A, and it takes 0.0074 seconds to travel to B, to get from A to B must mean that it is slowing down. And if it's slowing down, that means something also. If it's slowing down, that means that a force is acting. A force is simply a push or a pull. So there's two places in which we get a force, or that we can observe a force acting on this particular car. Two places where it's going to be accelerating it. And that's right here, the rubber band. The instant in which I let go, boom, it went from 0 to some speed. So it accelerated from 0 here to some velocity. In this case here, it accelerated. And as the car travels down the track, it has friction at the point of contact between the wheels and the actual wooden track itself. Therefore, that friction is going to be slowing it down. So you have two forces in play here. You have the rubber band that is accelerating the car from being at rest, right? If it was stopped and then all of a sudden it begins moving, we would say that it was let me draw a second car here, that car then accelerated. If its velocity here at the first initial point is 0 meters per second, and then it traveled to a velocity of say 2 meters per second, we would say that it went from 0 to 2 meters per second. And then last but not least, as it's traveling down the track, right, as it's traveling in this direction, friction is going to be a force that's acting or opposing its direction of travel. Force of friction is going to be acting against it. Therefore, its velocity is not going to be constant. It's going to be decreasing. It's decreasing because the force of friction is acting on it. Okay, that goes over parts. I believe that is where I want to stop off. And we'll start off with part D in a little bit.